In this video, we are going to dig deeper into graphing rational equations. To start off, we have some just-in-time review. On the first one, it says divide using long division. So remember to divide using long division. You take your divisor, 6x plus 3, and write it out front. And then inside, we're going to have 48x to the fourth plus 48x cubed minus 42x squared minus 3x plus 18. Make that 18 a little bit more clear. There we go. And so to do this, remember that you divide the first term inside by the first term outside. 48x to the fourth divided by 6x is 8x cubed. And I like to line up my like terms. And now we're going to multiply. 8x cubed times 6x is 48x to the fourth. And 8x cubed times 3 is 24x cubed. And then I am going to subtract. So when I subtract, these terms cancel. 48x cubed minus 24x cubed is 24x cubed. And I'm going to bring down my negative 42x squared and start this process again. 24x cubed divided by 6x is 4x squared. (4x squared times 6x is 24x cubed. 4x squared times 3 is 12x squared. And then I am going to subtract. 24x cubed minus 24x cubed is 0. Negative 42x squared minus 12x squared is negative 54x squared. And I'm going to bring down the negative 3x and start this process all over again. Negative 54x squared divided by 6x is negative 9x. Negative 9x times 6x is negative 54x squared. And negative 9x times 3 is negative 27x. So from here, I am going to subtract. So that will make these both plus. Negative 54x squared plus 54x squared is 0. Negative 3x plus 27x is 24x. And I'm going to bring down my last term of positive 18 and do this whole process one more time. And so I will have, let's see, 24x divided by 6x is 4. So plus 4. 4 times 6x is 24x. And 4 times 3 is 12. And then I am going to subtract. 24x minus 24x is 0. 18 minus 12 is 6. So when I go ahead and have this here, remember that this 6 is my remainder, so we're going to write it over our quotient. So we'll have plus 6 over 6x plus 3. So my answer will be my numerator up here, or my quotient up here. So I'll have 8x cubed plus 4x squared minus 9x plus 4. And then if I look at my quotient, I can reduce this. 3 goes into all three of these terms here. And so when I do that, I get 2 over 2x plus 1. This is my answer. If we look down here at the other example, it says graph y equals 2x plus 1. This is a linear function, and this is in slope-intercept form. Y equals mx plus b. I'm going to begin with B. B is 1. That's my y-intercept. I'm going to move with M. My slope is 2. So that tells me I'm going to go up 2 and to the right 1. I could also go down 2 and to the left 1. And I'm just going to do that until I fill out my whole graph. I'm going to connect my points to create a solid line and then use arrows on either end. So this is just some information that will help us with today's notes. Let's go ahead and look at this information down here. So here it says characteristics of rational functions. So your x-intercepts are the real zeros, solutions, or roots of the function. Remember that zeros, solutions, and roots all represent x-intercepts. All 4 of those words mean the same thing. To find the x-intercepts, you want to factor the numerator and solve. So if you're ever getting stuck on how to find your x-intercepts, you're going to set your numerator equal to 0 and solve that equation. Your vertical asymptotes are the excluded values. To find the vertical asymptotes, set the denominator equal to 0 and solve. Now you will have at most one horizontal asymptote or slant/oblique asymptote. So a slant asymptote is something that's going to look like this line right here. It's on a slant, right? We have a slope here. So we either say that's a slant asymptote, sometimes it's also called an oblique asymptote. The slant and oblique mean the same thing. So you will either have a horizontal or you will have a slant or oblique asymptote. You will never have both. So oblique asymptotes, aka slant asymptotes, occur when the degree of the numerator is 1 more than the degree of the denominator. To find a horizontal or slant asymptote, complete the following steps. So step 1 is to divide using long division, denominator divided by numerator. So here when you do this, you do bottom on the outside divided by top on the inside. You're going to ignore the remainder. You will have a horizontal asymptote if you get a constant, so if you just get a number. You will have a slant asymptote, so something that has a slope, if the constant or if the quotient has a variable. So that will be in the form y equals mx plus b. So let's look at some examples of that. On example 1, it says determine the asymptotes for each function. So we have y equals x plus 1 over x plus 3. To find your vertical asymptotes, this is when you set your denominator equal to 0 and solve. So here, my denominator is x minus 3. So to solve this, I'm going to add 3 to both sides and get x equals 3. So my vertical asymptote is x equals 3. For the next part, we'll figure out if we have a horizontal or an oblique asymptote. These go together. We either have one or the other, we do not have both. To figure this out, this is when you divide. You're going to do bottom on the outside, top on the inside. So our bottom is x plus 3 and our top is x plus 1. So x divided by x is 1. 1 times x is x. 1 times negative 3 is negative 3. So I'm going to subtract. X minus x is 0. Here I get 4. Now this is our remainder, so we can go ahead and ignore that. My numerator is 1. When you get just a number, then it's horizontal. If you get a variable, then you have an oblique asymptote. So here, because I have just a number, that means that my horizontal asymptote is y equals 1. I do not have an oblique asymptote, so I would say none. Again, If you have a variable up here, then it will be an oblique asymptote. If you get a number up here, then it's a horizontal asymptote. Let's try this again with example 2. So on example 2, first thing I'm going to do is figure out my vertical asymptote. To do that, I take my denominator, I set it equal to 0 and solve. So here I want to get x cubed by itself. To undo subtraction, I'm going to do addition and get x cubed is equal to 8. To undo a cube, I'll do the cube root of both sides. The cube root undoes the cube, that leaves me with x. The cube root of 8 is 2. If you're not sure about that, you can just type that into your calculator. So our vertical asymptote is x equals 2. To figure out if we have a horizontal or an oblique asymptote, I'm going to go ahead and divide. So my denominator goes on the outside and my numerator goes on the inside. So I'm going to do x cubed divided by, x squared divided by x cubed. Well, that doesn't go in at all. So if it doesn't go in, then that's 0. 0 is just a number. So I have a horizontal asymptote at y equals 0. That means that I do not have an oblique asymptote here. Let's try the next one. On example 3, my denominator is x minus 3. So I'm going to set that equal to 0 and solve. When I do that, I get x equals 3. So my vertical asymptote is x equals 3. To figure out if I have a horizontal or an oblique asymptote, I'm going to divide. So I'll have x minus 3 on the outside, 3x squared minus 14x plus 8 on the inside. 3x squared divided by x is 3x. 3x times x is 3x squared. 3x times negative 3 is negative 9x. From here, I'm going to subtract. 3x squared minus 3x squared is 0. Negative 14x plus 9x is negative 5x. And I'm going to bring down the 8. We're going to go ahead and keep going. Negative 5x divided by x is negative 5. Negative 5 times x is negative 5x. Negative 5 times negative 3 is positive 15. From here, I want to subtract. These will cancel. 8 minus 15 is negative 7. We ignore the remainder. In my numerator, I have a variable. That means that I have an oblique asymptote. So I'll have none for my horizontal asymptote because you either have one or the other, either horizontal or oblique. Since I have a variable, I know it's going to be oblique. My oblique asymptote is y equals 3x minus 5. So that is how you find your vertical asymptote, horizontal asymptote, or oblique asymptote. Let's look at example 4. Excuse me. On example 4, it says sketch the graph of the following functions and state the requested characteristics. So I have listed out all the steps for you over here on the right side. Step 1 says what are the zeros? Remember that your zeros are your x-intercepts. To find our x-intercepts, we're going to set the top equal to 0 and solve. So my numerator is x squared plus 2x minus 15. This is a quadratic equation. To solve quadratic equations, we can do one of the 4 things that we learned how to do: factoring, quadratic formula, taking square root, or completing the square. This one is factorable, so I'm going to go ahead and factor that. 2 numbers that multiply to negative 15 and add to positive 2 are negative 3 and positive 5. From here, I can use the principle of zero products and say, okay, either x minus 3 equals 0 or x plus 5 equals 0. To solve this equation, I'll add 3 to both sides and get x equals 3. For this one, I'll subtract 5 on both sides and get x equals -5. So I have two x-intercepts, one at +3 and one at -5. +3, 1, 2, 3, 4, 5, -5. So far, we have our x-intercepts drawn. Step 2 says, what is the vertical asymptote? To find your vertical asymptote, you set the bottom equal to 0 and solve. So my denominator is x minus 1. To solve this, I'm going to go ahead and add 1 to both sides and get x equals +1. So that means that I have a vertical asymptote where x equals +1. Step 3, is there a horizontal or an oblique asymptote? So this is when we're going to divide using long division. We're going to do the bottom on the outside and the top on the inside. So I'm going to have, let's see, my denominator is x minus 1, and my numerator is x squared plus 2x minus 15. X squared divided by x is x. X times x is x squared. X times -1 is -x. I'm going to go ahead and subtract. X squared minus x squared is 0. 2x plus x is 3x. I'm going to bring down my next term. Start this process again. 3x divided by x is 3. 3 times x is 3x. 3 times -1 is -3. From here, I can go ahead and subtract. These cancel, and I get -12. So I can ignore my remainder. This tells me that I am going to have an oblique asymptote at y equals x plus 3. So let's go ahead and graph that. So I'm going to begin with b. B is 3, so that's my y-intercept. I'm going to move with m. My slope is 1, so I'm going to go up 1 to the right 1. You can also go down 1 and to the left 1. And so this is my slant asymptote. So our slant asymptote was y equals x plus 3. We do not have a horizontal asymptote because we have a slant asymptote instead. Earlier we found that our vertical asymptote was x equals 1, and that we had two zeros, one at 3, 0, and one at -5, 0. Step 4 is to graph. So from here, I'm going to go ahead and plug in my original equation into Desmos. So I'm going to go to desmos.com/calculator, and I'm going to type in this function. So when I do that, I'm going to have, let's see, x squared. Actually, let me help myself out. I'm going to go ahead and tell it that we're dividing to start. So I have x squared plus 2x minus 15 divided by x minus 1. And so we can see the curve here and the curve here. And so when we go back to our graph with our asymptotes, that's going to help us a little bit better. So let's see. When I look at this curve, it looks like we're going through here and then getting super close to our asymptotes, but we do not cross or touch it. Same thing over here. Get close to our asymptotes, but do not cross or touch it. So that is what this example would look like. To find our domain and range, your domain are your x values from left to right. On this equation, my domain is going to be related to my vertical asymptote. So it can be all values of x such that x cannot equal +1 because we have a vertical asymptote there. Because my horizontal asymptote is none, that means my range is all real numbers. Remember that this capital R with an extra line is a symbol for all real numbers. If you wanted to use an interval notation, you could also say from -infinity to +infinity. If you had a horizontal asymptote, then you would use that for your range here. So for example, if this was y = 0, then you would say all values of y such that y cannot equal 0. Whenever your horizontal asymptote is none, your range will always be all real numbers. Let's go ahead and try example 5. So on example 5, we want to know what the zeros are. To find the zeros, you set your numerator equal to 0 and solve. So my numerator is 4. So I'm going to have 4 = 0. Well, 4 = 0 is a false statement. So that means I do not have any zeros, meaning that this never crosses our x-axis. For your vertical asymptote, that is when you set your denominator equal to 0 and solve. So I'm going to add 3 to both sides and get x = 3. So 1, 2, 3. Here is my vertical asymptote. To figure out if I have a horizontal or an oblique asymptote, I am going to divide. So I'll have x - 3 and then 4 on the inside. And we're going to say, okay, 4 goes into x how many times? It doesn't. So because 4 does not go into x, we get 0. 0 is just a number telling me that I have a horizontal asymptote at y = 0. So that means that I do not have a slant asymptote, because remember, you either have one or the other, either a horizontal or a slant asymptote. So you can go ahead and plug this into Desmos if you want. I know that because I don't have a reflection, that this is going to be over here and over here. And because A is 4, that means that there's a stretch. So I'm going to have a little bit of a gap. And so this one is going to look something like this. Your domain. Well, your domain relates to your vertical asymptote. So this is going to be all values of x such that x cannot equal 3 because we have a vertical asymptote there. Your range relates to your horizontal asymptote. Our range is going to be all values of y such that y cannot be 0 because we have a horizontal asymptote there. So this is what example 5 looks like. Next up, we have discontinuities, which are also called holes. So if a rational function has the same factor, x minus b, in both the numerator and the denominator, then there is a hole in the graph at the point x = b, unless the line x = b is a vertical asymptote. So let's look and see what this is. On example 6, I have x squared minus 4 over x plus 2. When I look at this, I know that x squared minus 4 is a difference of 2 squares. I can factor that as x plus 2 times x minus 2. And that is still going to be over x plus 2. Well, here, x plus 2 can cancel with x plus 2, and then all I have left is this guy right here of x minus 2. So y = x minus 2. I now just have a linear equation in slope-intercept form, so I can graph that. My hole is going to be where these canceled. Oops. So if I have x plus 2 and x plus 2, if we solve that, so here if I have a whole at x plus 2 equals 0, if you solve that, you get x equals negative 2. So wherever x is negative 2, so I'm going to go ahead and put that on my graph. Let's do it like this. Wherever my line is on this point right here, I'm going to have a hole there, meaning I'm going to have an open circle. And so I will, instead of having a closed circle there, it will be an open circle. And I'll show you what that looks like. So if we go ahead and graph this, I'm in y equals mx plus b. So I'm going to begin with b. B is negative 2. I'm going to move with m. My slope is positive 1. So in this direction, I have nothing to worry about. Over here, when I'm at x equals negative 2, I'm going to have an open circle there. So we can kind of get rid of this. So I'll have an open circle there, and the rest of them will be closed. When you draw your line, you have a hole at where x is negative 2, so your line does not go through it. So you just have an open circle at that point there, and that is what this looks like. So we say that we have a hole at x equals negative 2, or you could say that you have a discontinuity at negative 2. Let's try that again on example 7. So on example 7, I can factor this. Here, I'm looking for factors of negative 6 to add to positive 1. So that's going to be x plus 3 and x minus 2. Well, my x minus 2's can cancel. And so I'm just left with x plus 3. So my line is going to be y equals x plus 3. I can graph that. However, when I do, the x minus 2's canceled. So if I solve x minus 2 equals 0, then that means that I have a hole at x equals positive 2. So let's see. I'm going to begin with b. So b is 3. I'm going to move with m, so my slope is 1. So that's at 1. This is at 2. So I'm going to have an open circle here at 2. I'm going to keep going, and then go in the other direction. And then when I draw my line, we do not go through the hole. And so this would be what that graph looks like.